Hello, everyone, and welcome to the Geeknerder Podcast. I am your host, Kaivalya Apte, and today I'm joined by Peter from Percona. And it's a fully packed agenda today, so let's dive right into it. And welcome, Peter. Let's start with an introduction about yourself and about your journey into databases, about founding Percona, so we can jump right into the world of databases and understand it better.
Yeah, thank you. It's a great being here. Percona is an old company at this point, right? We are more than 18 years old, right? So a lot of what I would talk about is kind of ancient history by this time. I was born in Soviet Union, right? Obviously later changed to Russia, and I got started with using open source software and databases in the late 90s for another startup I was CTO of. And it was interesting. That was unusual choice at that point in time. And I think specifically in Russia, because you know what? In Russia, all software was free software, right? You can
Mm.
just go on the market and pay $2 for CD-ROM, and that would be your Oracle and Windows and everything, right? Which you can just use, right? But I chose a road well traveled and choose the open source software. And I had the pleasure of suffering with the very early versions of Linux and MySQL. And I think this is awesome, right? Because when you can get involved with technologies on the early stage, right, you get the experience which is very hard to get
Yeah.
years and decades later when it's so big, so mature, right? For example, I think few people realize Linux couldn't support files more than 2 gigabytes in size at that time. And that's one of the struggles, which would be how would you have to figure out to split your database so it can work
Mm.
with those Linux versions. That's where I got involved in MySQL. Then later I got hired by MySQL AB, and that is a company which were creators of MySQL. And that's, I think it was a glory time of MySQL, and it was a small, independent, agile company, and that was surely a lot of fun. Then I left that company as it was becoming larger, more enterprise-ish, and more boring for me, and started Percona, right? And with Percona, now we're very well known for a portfolio of open source software we produce, but that was not the case at that time. We started
Mm.
as like a services company, right? If you think about what Percona stands for performance consultants. That was our like a very specific focus. We would help a lot of like specifically Silicon Valley startups to be able to reach performance of their databases, MySQL specifically, right? Because they needed that, and then through that we grow and expand it to build software. Yeah, so I'll stop my monologue and let you to maybe ask some follow-up questions where you want to take it with more details.
Sure. Yeah. Thanks for joining me. And we are going to dive deeper into all these sections and databases, open source, SQL, NoSQL, Redis, Walkie, and all of that. And I've also asked some of the questions that I could ask you on Twitter and LinkedIn and Blue Sky, and people have also suggested some questions. So I'll try to accommodate that as well. Let's start with the most famous topic around Postgres and MySQL and how do they compare. Both have had like different trajectory over the last decade or something.
Mm-hmm.
And how do you see the rapid rise of PostgreSQL that we have seen in the past few years, like talking about different databases supporting and being compatible with Postgres protocol versus Postgres having this rich feature set, like supporting vectors and search and analytics use cases? Like, how do you see this?
Yes, I think that is a very interesting topic, right? And I think that is in particular interest of somebody who is like an old timer in the MySQL community. Because if you look at when Percona was started, 2006, the MySQL was pretty big, right? And the PostgreSQL folks were like, how can we be as big as popular as a MySQL is, right? And they often would have these questions like, why is the PostgreSQL, which is superior technology, but everybody's just using that stupid MySQL, right? And I would tell you the reason at that time, which I think was very interesting, and I think there's a lot of learning experience of that for developers building a new project, is what the PostgreSQL was much more elitist database, right? It's, hey, you know what? We are database for smart people. If you're not smart enough to figure out Postgres, you have no business in running databases. Things like that. It was like intentionally complicated. I think that complexity was a part of a pride and the culture of that core team developing Postgres. They would focus on like various, we want to support the SQL standard and do it the right way. And if it's not part of a SQL standard, we don't care. The MySQL approach was much more kind of hackish. MySQL came from the people who didn't give a shit about SQL standards, right, or anything like that, right? We just say, hey, we need to solve this problem. How can we solve it? If you think about early versions of MySQL, they didn't have support for subselects, subqueries. They didn't have a support for transactions even, right? You would have table logs, right? And it's, wow, this is bizarre. Okay, how can something like that be useful? But for simple web applications, that was awesome at the time. And then that built some other features which were quite useful. For example, MySQL replication. MySQL replication was always horrible. There was like always a whole list of features saying if you go there and there, it doesn't work. It was not like a complete, but you know what? But for a lot of applications at that time, it was also awesome because for simple applications, if you know what to do and what not to do, you can just like scale the MySQL easy and fantastically, much easier, right, than what you'd have to do with Postgres, for example, right? So this is all that awesomeness, right? But one thing I think what PostgreSQL had, this kind of like a secret weapon, which MySQL didn't have, is the PostgreSQL had this, it's a community project. Nobody, not a single entity owns Postgres, unlike with MySQL. And then it was like a small, this kind of like agile community-focused company that didn't matter, right? Really, they both really care deeply in the internet of community, right? But then MySQL was acquired by Sun was acquired by Oracle, and now that is a thing happens because you know what Oracles care about, right? Do they care about making a world a better place, or are they care about making more money for themselves? Of course, Oracle is Oracle, right? And I think that is where things have been like changing since that time very, very significantly, right? So you can see Oracle get like a much tighter grip on their commercial ecosystem in this case. And I think there have been a lot of vendors which see themselves in competing with Oracle. Think about like an Amazon, Microsoft, or like pretty much every big company out there have some beef with Oracle. So when you have a choice, hey, what database should we embrace and promote? Of course, that's Postgres. Why would you send a goodwill, traffic, interest to your bloody competitor? So that has been very helpful. That's everybody say, hey, you know what? If you have to choose just on the business reasons between MySQL and Postgres, that has to be Postgres, right? So that is one very big impact. But I think there is another one which is very interesting here, right? And it is the cloud, right? I mentioned about this kind of somewhat like an elitist approach with Postgres. And let me face it, like first, the usability of Postgres have been getting better, right? It always goes with like coalitions in the software. On one extent, MySQL gets a lot more advanced SQL features. On the other hand, PostgreSQL getting features what users broadly want, right? But here is another interesting thing. If you look for Postgres, developers start to love Postgres long time ago, right? PostgreSQL is awesome. It has a lot of very advanced SQL features, whatever, much more than SQL. And while PostgreSQL was great to use, it for years was bitch to operate. You ask developer and say, oh, now you have to set up a PostgreSQL, have ability with Patroni. It's, oh, kill me now. But guess what happened with cloud? With cloud, those concerns could be separated right now. You can just in a 2-click get yourself the managed instance of Postgres, which has high ability, backups, and you as developer do not need to care about that. So simplicity of running all the databases, especially in the cloud, has become the same for any database out there, right? And now we are not only talking about MySQL, about big expensive clouds like Amazon, right? What is interesting in this case is as cloud evolves, right? those database access, it became ubiquitous, right? If you go to something like a DigitalOcean, right, or many others, like you would also see the managed open source database offerings out there. And that is, of course, now makes it much easier for people to adopt all with obstacle removed, and if everybody hates Oracle, except people who work there. Some of them still do, but anyway, that is, I think, is a very big thing of a raise, right? And I think now it's interesting how we get like a circle back, right? Because now we in MySQL community thinking about, hey, what can we learn from Postgres? Is there anything we can do to reverse or slow down this kind of relative decline of MySQL compared to Postgres?
Interesting. Yeah, that's a very interesting take, and thanks for the sharing the insights about the rise of PostgreSQL. If I have to ask you, like in 2024, despite the fact that MySQL community is trying hard to change how things could work with MySQL and reduce the rate of decline of adoption of MySQL, in 2024, what is your take on, let's say, if I have to decide MySQL versus PostgreSQL, what are the parameters to decide?
Yeah.
Apart from, if I look at the trends, just the hype of Postgres, or let's say, what other parameters should I decide on? Would you suggest MySQL to anyone, or just go ahead with PostgreSQL? That's the
First, I think this is very important question, right? For a lot of applications, right, especially ones on a kind of a simple size, it doesn't quite matter. You can build them with MySQL. You can build them with Postgres. The performance difference is not going to be major, right, and so on and so forth. So in many cases, that is a question of a preferences, not for every application, right, but for quite large number of them, right? And in my opinion, so that means is if your organization, for example, have a lot of experience with MySQL and you are building like a new application with new team members, hey guys, you can just continue using MySQL if it fits well, right? Now, if you look at, I would think, the relation database, right, from out there in the universe, right, PostgreSQL has more momentum. That is good, right? That means more and more people will know it. It will be easier to hire people around. There's more choices where to find information, events, right, and so on and so forth, right? So I think the Post is a default choice from that kind of like an ecosystem standpoint, right? Now, if you think about Postgres, there are also some other things which are great in Postgres. For example, vector databases, right? A lot of people thinking about building AI applications. In a PostgreSQL, there is like a PG vector extension, there is PostgreSQL ML, and there's like a whole other ecosystem which has been developed, which is much more mature than in MySQL ecosystem. In MySQL ecosystem, Oracle decided, you know what? If you do AI, you should go to a heat wave. Screw you, right? Unfortunately, people much like it to go to Oracle instead, right? And I would say this is like an interesting, new, and very unfortunate choice. I would say what Oracle has been making recently, because for years, I actually was defending Oracle for many years after MySQL was acquired, because they have been a good steward. They have been developing MySQL in the best interest of community at large. Now it looks like they're saying, you know what, you are either pay to Oracle, go Heatwave, or you know what, you can just as well go to Postgres, right? We are actually not really interested in making the MySQL community attractive to you, right? And again, I think that is a stupid choice by them, but they have been choosing to shoot themselves in the foot, right? But, that is reality.
Yeah, I think it makes sense. So basically, people, if they have experience in MySQL, if their application can, the use cases can suit well for MySQL, I think let's go for it. But if you're more into, let's say, you care about the ecosystem, more use cases where Postgres features could be useful for you, then probably Postgres is an obvious choice. Even in 2024, is there like a really strong case for MySQL in terms of features that you think Postgres still lacks?
You know what? I think there are certain areas, right, which you can see what PostgreSQL have. For example, encryption, right? Like data at rest encryption, PostgreSQL, open source, like a core of PostgreSQL doesn't have, right? Which is to me bizarre, right? Because that's having such a commonplace, right? And in so many places, right? There are some replication options, right? Like a group replication, right? Or like what we have in the Percona's version as a Percona XRB cluster, right? These are also something which are different, right, from what a PostgreSQL have. For certain workloads, you'll find also storage engines, for example, MyRocks, LSM storage engine, which Facebook created and maintains, can be also better.
Interesting. Cool. We'll talk a bit more about like specific things in terms of PostgreSQL versions and the new versions and new optimizations. I want to ask you, since you have a lot of also consulting experience and working with databases and part of the community, what are the common problems? Because you mentioned that managing a cluster itself for a database, it's quite a challenging and complicated task, and you need to understand, you need to have a lot of experience there. What are the common problems that people face managing database clusters, be it MySQL or Postgres?
Yes, well, yeah, I think that is a good question. I think it's very like a broad set of issues, right? And I think it's interesting to see what when you talk about a cluster, you often can be talking about like such a different things, right? Sometimes you can say, hey, I have this kind of one little kind of small cluster, right? And that's one set of problems. Then you look at somebody what I would call like a Facebook scale, right? And thousands of nodes. That is completely different set of problems. The first thing I would say is probably making sure you have a good observability system, right? Or not enough observability, right? Because a lot of problems if clusters happen just because problems start to happen and then they just get ignored, ranging from things like, oh, you are about to run out of space and you are not monitoring that, so you run out of space, and guess what? If a database cannot write to a disk, then, well, it goes down or stalls cannot accept any more data. I would say things like that. If you look from developer standpoint, what I found often developers do not understand the databases very well, right? And that may come with putting some load on the databases with like some bad sub-optimized queries, right? And then surprised, oh, my database was overloaded in production. And that I think is a very important thing, right? Because database obviously only can do so much it's designed to do, right? And if you put too much stuff on that, you know what, even perfectly configured for a cluster will get overloaded and go down from user standpoint, right? I think that is where it's important to understand that, maybe to do some capacity planning to understand what this cluster will be able to deal with that new workload you're putting on it. Yeah.
Interesting. Yeah, that's a good point. And I believe if you take some services from the cloud vendors, you get some good machines available and you get some default configurations that is probably good enough for a wide range of applications. But then it boils down to the data model that you have. If you have modeled your database incorrectly, no matter how big machine you have, if you're querying in a wrong way or you're querying a lot of data in an unoptimized manner, it's not going to work. So
Yes.
that's a very important point.
Yes, what I want to add here, and I think that's interesting, if you look at the clouds, with the clouds, we are seeing a lot of horribly optimized databases, right? Especially in this kind of fully managed environments. And let me explain why, right? Because often when you come to a database vendor, they sell to you, oh, guys, you just run Amazon Aurora. It's fully managed, so you don't actually need your DBAs. You just as well can let them go, right? And what that often means is a developer, which may not know a database itself, is interacting with a cloud vendor. And then you come and say, oh, it's fully managed. Who's going to optimize my queries? You know what? That's your responsibility. But it's fully managed. Yes,
Yeah.
but haven't you read that shared responsibility? It's out there in small letters somewhere. And that often goes to a point that those systems are not optimized well, right? But there's also a second reason, right? The cloud is very easy to optimize by the credit card. And cloud vendors also encourage you to do that, right? If you come to them and say, oh, my instance is slow, right? They're not going to go and help you to optimize your queries, your schema. It's too hard, it's work. And that actually also goes against their financial interest. What they'll tell you is, have you tried going to a bigger instance size? Have you tried going to faster storage? And so on and so forth. And what that means is you have a lot of instances which are colossally over provisioned for the load, right? Which could be fixed with relatively simple optimization, right? We deal with that all the time. And that is different compared to all legacy data centers, right? Because you know what? The horrible and a wonderful thing in the data centers is, you know what? If you are running out of your servers, you can say, I need a new ones. And you tell, you know what? They will be available to you in a week, in a month, in 3 months. So what that means, you as a developer have to figure out how to make it work next week, right? For that next week or whatever. And that means you actually learn the skills how to tune it. And that's typically often means it becomes much better compared to that's kind of a hyper scaled cloud instance.
Interesting. Yeah, that's a good point. And from the developer's perspective, I think a lot of product developers probably do not go deep enough to understand what's happening behind the scenes and try to explain queries and understand where exactly we can optimize. Talking about this, what are some of the common mistakes that you've seen from the developer standpoint where, even at a low scale database volume, the queries were really slow, or like common problems that ended up in incidents or things like that?
Yeah, I'll give you probably couple of examples in this case, right? The one is not properly using indexes. The thing is, what a lot of developers do is they like testing their stuff on a very kind of toy databases. Right? Hey, that's fantastic. I have a 2 megabytes database. I can refresh it very easily, tear down, break it. And on one extent, that works wonderful. But of course, in your production, things can go completely different. And the thing in this case with queries, and that's I think which is often not very obvious to developers, right? Things can scale non-linearly, right? So if you have a very bad query with no indexes, you may have a 10 times more data, but the query becomes 100 times, or even kind of 1,000 times slower, right? Because of how it uses the data, right? And that means like you tested with the data, right? Not optimal indexes on a small data size. You put it in production then, and then even one horrible query can completely overload your instance. So that is, I think, the first thing. The second thing is the opposite, right? And that goes maybe together, right? I remember coming to the customers, to the customer once, right? And they say, you know what? We found a way to have MySQL to work very predictably. It gives no surprises to our developers. Like, it's awesome. And I say, oh, wow, what is it? And they say, you know what? 3 rules, no joins, right? Well, of course, in this case, we actually give up majority of awesome functionality of relational database. What you can have a data joins, right, and all those kind of changes on the databases and make the applications more efficiently, right? But a lot of people do something like that, and what they end up doing is a lot of queries, a lot of simple queries, but if the latency adds up. And this especially becomes bad when you move from your application running, let's say, on your laptop, where your latency is very slow, to where database and server are separated by the network. And especially if you happen to need to operate from different availability zones and in a failover scenario, stuff like that. So thinking about that is very important. I have seen the cases, for example, where the single web page would generate 100,000 of queries to be generated. And think about that, right? Yes, if you have a very fast laptop, 0.1 milliseconds, it creates kind of 10 seconds. It's not fast, but it's doable. Now you move that to a network and you have a 1 millisecond latency. Boom. It's about 2 minutes already, right? And if you go to 1, oof, right? So think about that latency matters.
Interesting. Yeah, I've seen one use case in production environment where we just said no foreign keys, no joins, and just use MySQL as a simple database, like storage, like simple data modeling. But then I think the problem was we just moved the problem from one place to another, and where at the application level, basically, and we had to complicate a lot of application logic. So maybe for some use cases it might work out, but again, you have to understand the trade-offs, right?
Oh, yeah, absolutely. And I think this is interesting what you mentioned here, right? Because if you think about this, right? Of course, for some simple application, you start with that becomes very easy, right? But if you look at a long period of time, then things change. Application gets more and more features, right? And that often becomes, it was very easy to create, but that was hard to maintain, right? With that, we can have this like a little maybe quote about a schema-less databases, like or document databases like MongoDB. You can say, hey guys, it's wonderful. You don't need to have a schema, right? Look at that. You can just put wherever it is in your database. But then they come over a point where that does not really work over a long time. You need to have a rules. Otherwise, it becomes mess. Again, if you just want to prototype a demo, launch something over your weekend, fantastic. It makes it easy, right? And then it came to another definition, right? We're saying, you know what, guys? Actually, there is always a schema. You just have to choose if that schema going to be in the database and if it, or a schema going to be in application. And in many cases, when you have a database which is utilized by multiple applications, it's much better to have that schema in a database, because otherwise those all the different applications will start to disagree about what the schema actually is, what versions of a schema should be supported and stuff like that.
Agreed. I've seen that once. And as you said, if your application is simple, yeah, go for it. I think it might work out. But as you have more clients, more applications, you have to duplicate a lot of code, and then you diverge in some of the code, and you ended up in correctness issues and inconsistent data in your database. And then you have to run some scripts and figure out if there is inconsistency. So it just adds up to the complexity, and it's probably not worth it for many use cases. Since you brought up MongoDB, right? Let's talk a little bit about MongoDB's success when it comes to NoSQL. That probably became like a default for application developers. Oh, let's use MongoDB, and now the difference between the use cases of NoSQL, or let's say I want to use Postgres, are becoming a bit blurry. And Postgres is supporting a lot of those features as well. For example, storing JSON, storing documents, and search and analytics use cases, and so on. So where is MongoDB going, and what is the reason for its success over the last few years?
Okay, let me once again maybe take you on a little bit of a historical journey, right? So you think about the databases, right? Initially, there have been a lot of databases like navigational databases with complicated APIs, right? And if you think about the SQL, now like probably like about 50 years ago, it actually came to exist as a simple language which operators themselves could use, right? You have a terminal, right? And you are like the system user, boom, you write the SQL and that works, right? But now if you think for many decades, or starting with the decades, there have been few computers, and the people who would work with them would be highly trained. Even in my time, right? If you look at the late 90s, you know what? Typically, it was like a relatively small amount of this kind of like a weird computer geeks who would often will be like a math whiz, trained in computer science, and so on and so forth. And then what happens is now computing is everywhere, right? And MongoDB was very successful riding that wave. The SQL became too complicated for a lot of people. When you see some people, hey, building simple apps, web apps after 2 weeks of coding boot camps, you know what? SQL, relational algebra, damn it, too complicated, right? As MongoDB, which often would have that kind of a native integration with programming languages, right? Where you don't even feel like you're using database, right? You just have the same way you natively work with the data in your programming language, JavaScript or Python, wherever. Just have some of it happen to be stored in a database, right? That was very addictive to a lot of developers, and they got fantastic mind share. But here's, I think, what is an interesting, right? And again, I'm talking like only on the usability, not about they're screwing everybody with a license change and everything. I'm not quite sure what the future is so rosy for MongoDB. And why? Actually, for the same reason. Because what we have right now, what is a state of art of simplicity? It's AI. Now there is a lot of fantastic applications. We just write a prompt and say, I want application to do this, and it does this. And you know what? It can do this with Postgres, right, or with Mongo. So that kind of competitive advantage of simplicity, which MongoDB used to offer, it goes away. So I think that is a very interesting trend. And I know MongoDB is trying hard, right, to invest also to how we're going to work with that AI platform in this case. But I think that is something where things can be changing again, right? If somebody Postgres, right, is so ubiquitous, which can do a lot of things, right, and less restricted when the document data model, what MongoDB comes in, things are going to be interesting.
Yeah. Absolutely. Since you talked about license changes, right? Redis also recently changed its license, and there's a lot of discussions around that. And then, what are your thoughts on Redis's growth and the development around Walkie, where that kind of world is going, and how is the adoption in terms of Redis versus Walkie is looking, and where do you see the future of it? Um,
Let's again maybe elevate the question, right, if you don't mind a little bit,
yeah.
right? We had seen the trend
Mm,
in this case of the companies changing the license, right, from open source to non-cloud, non-compete, right, for a number of years
mm,
right now. And to a certain extent, that's even became just like a bait and switch thing, saying, hey, we're going to create this kind of open source projects, and awesome, please go ahead, come to that, and then boom, now we became ubiquitous, let's change the license, right, and then just monetize that ecosystem heavy, right? And that's what like a MongoDB did, and Redis did as well. I think there is a lot of very hard feelings about Redis specifically, because when the Redis project creator was leaving, they say, no, guys, don't worry. Yes, there have been some extensions which Redis Labs created. Yes, they are going to be licensed about this non-open source license, but Redis is FreeBSD forever. I give you my word, right? But guess what? That forever was like 2 years, 3 years, right? And then the license was changed, right? But here I think it's also very good to see how the open source community reaction of that involves. Think about that. 2018, MongoDB changes license. Nothing happens. Everybody just sounds like too bad, right? Swallows it. Now, the next kind of big adopted open source license project to change the license was Elastic. Elastic changed the license. The open source fork immediately happened. It was done just by Amazon. It was not like a whole like a ecosystem fork, right? If you will, and it's only later became managed by their Linux Foundation. But I think that's very interesting. What fork happened, you could see on the adoption graph what like an open source is going very high, right, and then Elastic is falling in popularity, right, to the point what like a few months ago, the Elastic came and said, guys, you know what? Okay, we are going to go back and we are going to use different open source license, but we are going to make Elastic available on that again, right? They are, I think, trying to stop the bleeding, but I think which is too little too late, because after you already showed your few true colors to community, it would be very hard to undo, right? And then that brings us to Redis, right? The thing with Redis, which was wonderful, is what in a very short time after they changed the license, where this was well organized, managed by very respectful foundation, Linux Foundation fork, Valky came to a point.
mm.
And with this fork, you can see a lot of companies which are bitter competitors, Oracle, Amazon, Google, coming together to maintain that. Percona, yes, we also support that, but of course we're like a small fish compared to all those big guys. And now we see that it's in early days. It's what I think it's even hasn't been years, but there is a lot of interest. It's good to see what Amazon have been rolling out commercial projects, a lot of stuff. I think they have been also making that more attractive for customers from a pricing standpoint to move to Walkie, right? So I think that is going to be, there is a fantastic future for Walkie. And what I'm also hoping, in this case, what maybe that gives us sort of also acts as a prevention for other communities, right?
Mm.
If those kind of companies, right, the corporate sponsors that say, hey guys, you know what, if you are really going to treat us poorly, we're just going and fork that project, and that fork is going to be successful, then probably more companies would play nicer.
Yeah, that's a very good point. Yeah, looking forward to development in the area of Walkie and how it competes with Redis and the adoption. Since you also mentioned about with cloud and you took us through this journey of people who were managing Postgres and it was really complicated, but with cloud it has become better. I want to understand from your perspective with the rise of Kubernetes in terms of database development as well, what unique challenges and opportunities in the world of databases in this cloud native environments with
Mm-hmm.
Kubernetes?
Yes, of course, of course. I think, yes, as we discussed, what their cloud has been wonderful. There have been a lot of this very good usability proprietary solutions builds, but that also comes with cost, right? They
Yeah,
typically can get rather expensive, right? And often those kind of comes also with a loss of flexibility, right? If you're using Amazon Aurora, for example, which may be wonderful, but you know what? It only runs on Amazon, right? And it's also have that very much controlled Amazon pricing. So it's not really different from running Oracle database, right? Even if
yeah,
it's open source compatible, right? Now, I think what is interesting, right, as we can see in a world, let's say, of operating system, Linux was not the first operating system to come, right, in this case, but then it came to this kind of big dominance. The same thing we can see in a Kubernetes and cloud native ecosystem. You can say, hey, you know what? Okay, we built this kind of like a Gen 1 proprietary cloud system. Now let's us actually treat clouds as a commodity. Everybody can provide us a bunch of servers, storage. It doesn't
yeah,
matter if it's GCP, AWS, Azure, the same stuff, right? And then we can build our infrastructure on that by using Kubernetes and other cloud native technologies, right? Which is awesome. Now, if you know a thing or two about Kubernetes, you may heard it was created for stateless applications, which is absolutely different from databases. But
yeah,
now it got a lot of support for stateful applications. In fact, I went to a KubeCon, what is like last week. We had this data on Kubernetes day with a lot of companies, including banks, right? Like some big American banks talking about how they are using data on Kubernetes successfully. So it's pretty much ready for prime time, right? And what usually, so you can run databases on Kubernetes, right? With if you are kind of Kubernetes natives and you understand all those kind of manifests, YAML files, wherever, you'll find working with operators awesome. It's you just define the infrastructure, boom, it's deploys, it can be doing the backups automatically, you can configure that to be automatically scaling, right? Like awesome stuff that you can do in this case. Now, if you are looking for something more as a similar to RDS, like a managed database, that is where you can also use the open source product what we built at Percona. It's Percona Everest. That's GUI, which is very similar to those folks, and that works on top of operators. And why is that awesome? Because you can mix and choose, right? You can say, hey, you know what, for I first do this kind of manual management, provision, and so on and so forth, and then I can also add some more operator-based automation in my book.
yeah. Interesting. Since you talked about the Everest project, and it also mentions about the vendor lock-in that you get the database as a service like flexibility without the vendor lock-in. Where
Yes.
does what exactly drives this vendor lock-in, and is it more like cost of migration, or it's really like a lock-in? And what helps in Everest to avoid
Yeah,
that?
that's right. I think that's a very valid question, right? If you look at this case and say, guys, there is an Amazon Aurora by Amazon and there is a Percona Everest by Percona. Both are like this vendor products. So what is the difference, right? The core difference in this case is what if Everest is a open source project, right, which you can use without having any commercial relationships with Percona, right? We hope that you will go ahead and use our support, managed services, right, which comes with that. But you know what? If it doesn't fit your budget, if you're not happy with quality of our stuff, you can go ahead and run it yourself. And that is, in my opinion, which is quintessential to their vendor lock-in, right? If you look at the commercial vendor lock-in, that is means what there is a single vendor, right, and they can essentially dictate the rules, dictate the pricing. If you don't have that, then you have a choice. In open source, this typically comes as a choice of having multiple vendors or ability to take it in-house, right? For example, if you run Percona Everest, Percona operators, Percona database software, hey, you know what? Maybe you don't even hire anyone, right? You can just train a couple of people who are familiar running that software for you and self-support. And that is a very important choice, right? And what cloud vendors like to do, right? They can say, oh, you know what? There is actually always vendor lock-in. And what they mean is there is always technology vendor lock-in, right? But you can say, well, you know what? If I am using Postgres, well, it's hard for me to go and move from that Postgres to MySQL, for example. So you are locked in with a Postgres, of course, right? But of course, what they don't tell you, what it is completely different. There is thousands of vendors which can help you on commercial basics, right? With PostgreSQL, right? While if you're speaking about like a proprietary technology, you have to deal with a single vendor, right? In this case, at least to get the licenses, support, and so from them. So I hope that kind of clarify things a bit.
Yeah. One thing that I'm also mixing the two topics that we have discussed. One is about how things have become easier with cloud to manage a database cluster, also for the application developer side. And I also want to bring in like how Percona is trying to address this challenge. At least in my experience, I've never seen a database migration or a database upgrade being a very seamless process, right? There has to be some downtime, and there's always some manual things that do not work, because in modern applications, at least in my experience, you have a database, but then things do not stop there, right? You also have replication in place. You also have, let's say, CDC, Debezium that emits some events into Kafka and so on. There are connectors. So we have to take them down, do the upgrades, do the migration, change the LSN and do something. There's a lot of moving parts and things can go wrong, and application availability is also impacted.
Yeah.
So how do you see this problem being solved in today's world and also in coming future?
Yeah. Okay. I think that's indeed a very interesting and an important question. First, if you think about the databases, I think there are two types of upgrades, right? What you deal with, right? One is a minor upgrades. Typically, hey, the new version comes with security updates, like boom, you want to upgrade it quickly, often, and hopefully it can be done uneventfully. If you're running something like an operator in Kubernetes, it often can be completely automated, right? Now, there is also those kind of major updates, right? And frankly, some minor updates turn out to be major updates as well.
Yeah.
That is where you may need to change your application. That feature you relied on doesn't work anymore, right? And that is always challenging. Frankly, it is not just really limited to a database, right? Often I've seen people saying, well, now we have to upgrade to a Python 3 because Python 2 is not supported anymore, right? And you know what? We have to go and deal with all this kind of stuff, right? But the thing with the application, right, because it's kind of stateless, it's often much easier. If you can say, hey, I just had this kind of a rolling restart, right, moving 2.7 to 3 with Python, you can do it. If a database you accept a single consistent copy of the data, and that makes things much harder. Also, if you screwed up your update, it's typically you just say, you know what, let's start over. If you crash your database, it becomes problematic, right? Some of this kind of answer may be not satisfying, but that is just the truth, right? There is no after magical major database upgrade. What is very important is what you in your development team work with, whoever you're, like your cloud vendor, your whatever your DBA team, right, to really plan and execute that upgrade together as a team. Assume, hey, as a development team, you may need to make some choices, to make some changes in your environment for that to work.
Interesting. Yeah, I think what you're saying, and correct me if I'm wrong, there's always going to be some tight coupling with the application and how it is developed and how your abstractions are laid out. You have least impact, as low impact as possible on your application availability with these upgrades. And then you need to always work closely with your cloud vendors and your DBAs to make that process simpler. And I think what, in my experience at least, makes this a little complicated is that a lot of companies use cloud vendors, but they still have some wrappers around it or some kind of scripts that work with the database, and that those are the moving parts which makes it really complicated. And there are bugs that do not work, things change and stuff like that.
Yeah, absolutely. And again, that is a problem is what with databases, often you need to test things much, much better because often you have different chances, right? If website, you
Yeah.
can say, oh, I deployed something, oops, it doesn't work. You know what, this was 30 seconds, nobody noticed that, who cares? But if
Yeah.
you oops your database, then that is a problem. There is like a data loss and so on and so forth. And I think what is also like important here, right? What you're saying, there are some things in application. The challenge what I see often in a database is those things. It's not like a well documented, described in comparability, but there may be certain things which you rely in your application without knowing you rely, right? For example, you may say, I'm not sorting the data, but I'm relying on some particular order of the rows what I'm getting. Maybe without knowing to, right? Because it's just a rote application running through a test. The new version use a different optimizer plan. The order of data comes differently. Your application breaks. Well, actually, nothing became wrong, right? It just you're
Yeah.
relying on the things you shouldn't, right? Or performance, that is also like a very important thing, right? The thing with the optimizer plans in particular is very interesting, right? Because when you speak about like a new version has a better optimizer plan, it can handle more queries. And what that means is saying, you know what, maybe 90% of queries becomes faster, but then those kind of 10% of the queries which become slower. There's always some regression, sometimes significant. And that is, again, goes why is you need to make sure to test those things carefully and so on and so forth. And for large companies, right, it takes a lot of time, right? I have been following Facebook, for example. Often they will say, it takes us like a year or two to upgrade from one MySQL major version to another, right? It's just
Yeah.
because we have so many complexities, so many tools, applications, so on and so forth. And other massive complicated deployments often typically take time as well. It's not just, boom. Uh, and you upgrade it. So anyway, plan it, test it, and I would suggest just don't expect magic.
Yeah. It's a complicated world. You need to understand your workloads. You need to test your system. Yeah. And be ready for the challenges. Talking about testing, though, there's a specific type of testing which probably could uncover some of the performance bottlenecks. Like, for example, load test. Like, people, like some companies have like specific days, like Black Friday is coming, and they want to be prepared and understand if their queries are optimized and their database workload can be handled. There's always like different challenges around that. Like, how do you load test and be as close as possible to the production environment? And it's always
Mm-hmm.
difficult, and also simulate the type of traffic patterns that you have seen probably in the last year or last Black Friday. And I've also, again, always seen very few companies do that actually in production environment. But then there are other challenges attached to it, that they have to delete all the fake data or the test data they have created. Otherwise, it's again a problem. Or they just end
Yeah,
up creating a test environment where they do this load testing.
yeah.
What are some strategies that you have advised and you've seen working quite well?
Yes, a couple of thoughts here. One thing, if you look at the cloud, right, what makes cloud wonderful is it's dynamic,
Yeah.
right? Because if you're doing kind of major rollout, right, in this case, you would want like a physical data center say, hey, I need 100 servers. It's, whoa, that's too much. Now, if you want to run 100 servers for a day, right, because you need to do load testing, that's
Mm.
both available not too expensive. And I think that is what is very helpful. Yes, you may be testing like on a small environments, but you know what? If you want to have something major, in this case, then do that. In terms of testing, I think it's often very good idea to do both like a full text stack test, and then you have some load tests like a generated transactions to run through all your applications, as well as micro tests for most kind of critical transactions. You can stress
Yeah.
database infrastructure in particular. But here's also like an important thing, right? We started this talk by talking about observability. The reality is you are not going to catch all the problems in testing. I'm not sure if you're like an aviation geek, right? But if you follow what they're doing is wherever they find some sort of anomaly with a plane, something goes wrong, right? Then they go and figure out what went wrong. They refine the operation guides, maybe design some bits and pieces, right? And if you're thinking about mission critical systems, right? If it's something like really important, that is a process you need to follow. That is in this case. And what is important for that? Why they're able to do that for plain? Because they have awesome observability, right? All those kind of many dashes or whatever. It's tons of data being captured and stored, right? In addition to what's being designed, right? So you then can understand when things go, then you probably can prevent them before they become critical and user impacting. It's like, again, with planes, you fly, you probably don't really hear anything, but actually for you it's normal flight, but for pilots it may be like, oh, you know what, that engine is running slightly hot. Oh, it looks like those tires need to be replacement. All of those things are done proactively. Again, good observability system can help here. And I'll do like for some little plug here, like one of the systems, like one of the projects I'm working on, is called Karoot. It's this like a pretty cool observability system, right? Which is easy to install, but it has a very good complete coverage of all your environments, hopefully to help you to prevent the problems or resolve them quickly if they happen.
Interesting. Talking about observability, right? I've seen many dashboards created by different teams, by DBAs. There's a ton of information there, like probably the top used indexes, top unused indexes, the index bloat size, and the table size in general, and the CPU, and all these other metrics. Also, the ones that you get, for example, on RDS, like basic metrics around that. But what are when we talk about observability, right? Of course, only at the database level, what are the top things that you think people should monitor, and basically it can cover majority of the use cases
I
for them?
think you're absolutely right, and I think this is often goes as more, sometimes less is more. And what I like to tell is what, hey, your observability solution needs to be usable for a user who is going using it, right?
Yeah.
I have seen a lot of very advanced database monitoring tools, including Percona PMM, right? It is awesome for DBAs. They love it. It can go in a very deep problems in a database. But when you go to developer and you look like, what the hell is that? There's like thousands of different graphs here. They all look, I don't even know where to look.
Yeah.
It's too complicated for me. So that is, I think it's important to have observability on that level, right? And that's, like I mentioned, Karoot. In that product, we chose, hey, how we can give you bare minimum, right? In this case, so you can avoid that information overload, right? But going back to the database, like you're thinking of what are the bare minimums. What I like to think in this case, and that kind of connects a lot of SRE practices. You can say, look, a database is a service, right? What exactly you expect of that? I can connect to a database, right? No authentication errors, right? Or just whatever, some other problems, right? And then I start hammering that with queries. If those queries respond to me with a good latency, good response time, right, and they're not throwing the errors, that's good, right? That is the main thing what the database is operating normally, right? And yes, addition to that, you can measure CPU usage, hits ratios, like yada, yada, right? Which just can help, but that is your primary thing, right? If a database is responding slow, it's bad. If it's responding good, it's good, right? What I also like to add here, often you also want the correct responses, but observability system often cannot validate that, right? You have a query. In this case, how does the system know if that's right? And that is things that typically covered with testing, right? So in a testing, you hopefully can validate, right, what things are working correctly, right? Sometimes people have some other additional check scripts, right? If a like to make sure that the data is consistent in accordance with business logic, but that does run asynchronously, and your observability systems ensures that's very primary error rate is low, latency is good, and I think that's
Interesting. I think that's an important point, and I've seen testing like right from your test containers where you spin up a database and also test some compatibility, let's say new features and all of that. From there to the synthetic tests where you have an application in production and you create like a user, you try to simulate a user transaction and test things. So I think testing at each layer is definitely very important.
absolutely.
And then observability, as you mentioned, think from as a service perspective, like what your user wants, and start from there, and probably go deeper into understanding, oh, okay, my latency is shooting up. What is happening? Probably CPU, or probably indexing problem, or probably some queries just taking locks and so on. And because when I go to the RDS, the UI, there's so many things happening, and you see the wait times for each queries and the disk usage, and it cannot always translate to the query performance, like what exactly is happening from the application's perspective, right? Of course, there's a lot of information that I could probably dig deeper, go into the rabbit hole and find nothing. But then if you start the other way around, that the query latency, probably there is more signal to it.
Yeah, absolutely. And I think what is also important here, right? I mean, if you think about this, in a lot of kind of large organizations, the
Yeah.
ownership is split, right? It's maybe, you know what, I am responsible as a developer, but I have a cloud vendor, right? If you have a good observability system, I think first it should be for a developer to understand where to go. Like you want to go and say, oh, hey guys, you know what? I am seeing from my system what the database is responding slow to me, figure it
Mm.
out. And you want to be able to know that what that is a database, and not, let's say, ChatGPT API is slow today, because both those can translate to like your pages are slow, right? So
Yeah.
first you figure out who's responsible team and a vendor, right? And then work with them, or maybe use appropriate tooling for that, right? For example, we see a lot of tools which are very good in helping you to troubleshoot MySQL or Postgres. But to have a holistic view, a very complicated system, right? There are a lot of microservices talking to each other and can say, oh, that is where the problem is. Then that is where I need to go and fix it. That is typically is a harder problem in those cases, right? And that is the most important to cover.
Yeah, totally agree. Interesting. As I mentioned earlier, I have asked some of the viewers who would be interested in asking me some questions to you. I've tried to accommodate all these questions while we are talking about different things, but there's one question that probably is more direct in that sense. So it's about when can the community expect a downstream binary drop-in replacement for Heatwave from Percona?
Look, a front answer in this case so far, we do not work on that, and that would be like a strange to suicidal, right? Because if you think about this, let's say like an Oracle has a very large team, they're building that kind of something. Can Percona alone? I don't think that is exactly the path which is going to be direct, right? What
Hmm.
I think in this case is likely to happen is the solutions from community to come in a different form, and they are already coming, right, in different ways. For example, there is, if you look at the implementation of a vector functionality, it already exists from MariaDB, right, the MySQL variant, as
Yeah.
well as there is work done by PlanetScale, right?
Hmm.
We as a Percona considered maybe we will adopt and include one of those solutions in our distribution. Right now, if you're thinking about, oh, but what about this kind of like an awesome acceleration of analytical queries? There are some solutions as well out there, right? For example, the ClickHouse, the very popular, fantastic, very fast relational database, right? It can already speak MySQL and Postgres protocol, right? And there are tools how you can replicate the data from MySQL to ClickHouse, right, to PostgreSQL to ClickHouse, not dissimilar actually how Heatwave works internally. Now, I also want to mention the guys, there is a MySQL compatible database, PinCaps DB. It's also an
Yeah.
open source database, which actually is something which gives you a lot of the same kind of Heatwave functionality. It's not by Percona, but it is an open source technology which exists out there. And I think that is, I would just say, if you look at from Percona, we always try to be very mindful where we can create value, all right, based on the resources what we do have available, right? Because, well, unfortunately, as any business, right, you have some constraints, and there's typically a gap between what you as engineer would say, oh, that's something like a wonderful what I would want to do, versus what you can do, right, while running the business.
Interesting. Sounds good. One more question, and I think it's probably less technical from, but people have asked this from more like a careers perspective, like from engineering and database administrators. So as you might, I believe that this role called database administrators is declined, like in terms of number of open jobs or requirement for database admins, because as you said, with cloud, you use database as a service, and you don't have to feel the pain of managing the cluster and so on.
Mhm.
So what should database admins do in that sense to still stay relevant? And the other question I have is more from the application development side. Like, people tend to understand the application behavior, the features they are developing very well, but then when it comes to, let's say, optimizing performance specific to database, they lack understanding, they lack expertise. So to grow in the career, what is your kind of advice to the community of database administrators and developers to still be relevant and understand the database world a little deep enough to solve their problems?
Yeah. Okay. I think like there's two questions here about the database administrators and
Yeah.
the developers. First thing about the database administrators, I think it's interesting. There is think about like we have a databases and more databases coming up, and they're still taken care by somebody. Maybe those people are working by cloud vendors or somewhere else, but there is still, I would say, demand out there. Their role, those have been changing, and often it's also changes a different name for that. I see, for example, a lot of SRE just take care of a database, so DBREs, right? Or you have some other titles which get responsible for that. Now, some of that I think is get integrated to it, right? But I think what that means also, what your role is likely to be evolved, right, from a classical DBA. And I think that you need to go on the new skills. Specifically, there is a lot goes now in this working with the databases as a part of platform engineering, right? You are expected maybe to learn to know how to code, at least on the infrastructure side, right? How to write whatever it's recipes, right, or wherever it could be, right? And not just be I'm a DBA, I know where to click, right? That's ClickOps DBA, which we used to have ages ago, right? So the same, I would say, with developers. Like I would suggest to learn about the databases. I think that's very helpful. Learn how databases work, how to optimize them, and so on and so forth. I also think we are in a very interesting time in the market because we are talking about their AI having a lot of disruption, especially on the lower end for both positions. Then I think that is like what I would encourage everybody to make sure not ignore what AI can do and say, oh, these are toys. They cannot replace me. They can only replace very junior engineers this way. But embrace that, embrace AI-based tool which exists for databases for development you are doing, right? Because then what's likely to be in this case is what the expert plus AI technology, right, is that secret power, which is what like gives you that kind of 100x productivity, not just AI alone, right? And you want to be that expert, right? Because you know what, chances are will be less requirement of developers who don't know AI, right, or database guys, right? We just want to hold the database old-fashionedly just.
I think that makes sense. Are there any specific resources you recommend in general, you keep referring to, or some of the classics or even the new resources? Because there's just so much information out there. Like sometimes people get overwhelmed.
Oh yeah, that's hard to say. You know what? If you look at what I consider relevant, I'm obviously an obsessive social media posts, right? For example, on LinkedIn, especially, so a little bit on X as well, right? So if you think that, hey, I want to know what Peter thinks relevant, right? You can subscribe to that feed. If you look at in general, I do follow like a hacker news. I think that's interesting. There's like momentum, like an interest is going, right? That typically gets out there. As well as over time, what I do as I flow through internet, typically I try to subscribe to those individual offers, which I find particularly interesting because again, in a social media delivery, especially those days, you may be otherwise missing the most important thing you want to know. Yeah, so that would be my fan.
Interesting. Thanks a lot for joining me today and sharing all the amazing journeys of these different databases and talking about the trends and talking about the licensing changes and how you see the community evolve. And also the advice for engineers out there who would be watching this episode and trying to dig deeper in the world of databases. So thanks again. And I loved recording it.
Thank you. That's a pleasure.